The ocean is silent. Then, it moves. Something massive rises beneath the surface. Not a ship, not a submarine. Something alive, ancient. Sirens erupt across the coastline. And then, from the horizon, steel giants emerge. A machine the size of a skyscraper steps into the water. Each movement shakes the earth. Metal groans under impossible weight. Inside, two pilots lock minds. Heartbeats sinking, thoughts merging. Pain is becoming shared. This isn't just a weapon, it's a last stand. But here's the real question. Could humanity ever build something like this? In Pacific Rim, Jaegers are humanity's answer to extinction. Giant humanoid war machines built to fight monsters from another world. They are fast. They are powerful. They are controlled by the human mind itself. But strip away the cinematic spectacle, and what remains is a terrifying engineering challenge. Because building a Jaeger isn't just difficult, it might be one of the most impossible machines ever imagined. Let's start with the most obvious issue: size. A typical Jaeger stands around 250 feet tall and weighs thousands of tons. That sounds impressive until physics steps in. There's a principle known as the square cube law. In simple terms, when something gets bigger, its volume and weight grow much faster than its strength. So if you scale a humanoid robot up to Jaeger size, its own weight would crush it. Legs would buckle, joints would fail. Metal would tear itself apart under pressure. Even modern marvels like skyscrapers don't move. They're designed to stand still, because movement at that scale is dangerously unstable. Now imagine that same mass, trying to walk. Every step would generate shock waves through its structure. The ground beneath it could fracture. Cities wouldn't just be defended, they'd be damaged by the very machine meant to protect them. This isn't just an engineering problem, it's a structural nightmare. Now let's assume somehow we solve the structural issue. We build stronger materials, reinforce every joint. There's still a bigger problem: power. A Jaeger doesn't just stand, it fights, punches, runs, lifts objects heavier than tanks. The energy required for that is unimaginable. To move something that massive with speed and precision, you'd need a power source far beyond anything we currently possess. Even the most advanced nuclear reactors today couldn't safely fit inside a moving humanoid machine. And if they did, you're walking around with a mobile nuclear disaster. One failure, one breach, and the Jaeger doesn't just fall, it becomes a catastrophic explosion. Some concepts suggest futuristic solutions: compact fusion reactors, advanced energy cores. But as of today, those are still theoretical, meaning a real Jaeger would either run out of power in minutes or carry a power source too dangerous to ever deploy. Either way, it doesn't survive the battlefield. Now we reach the most fascinating and disturbing part of Jaeger technology: the pilots. In Pacific Rim, Jaegers are controlled through a neural link called the drift. Two minds connected, acting as one, because no single human brain can handle the load. And here's the shocking part: this idea isn't entirely fiction. Scientists today are already working on brain-computer interface systems, technology that allows the human brain to control machines directly. Companies like Neuralink are developing implants that can translate thoughts into digital commands. Right now it's basic: moving a cursor, typing with your mind, but scale that up, and you begin to see the possibility. However, controlling a Jaeger wouldn't just be complex, it would be overwhelming. You're not moving a cursor, you're controlling thousands of tons of metal in real time, feeling its balance, reacting to impact, processing massive sensory input. A single brain would likely overload, which is why Pacific Rim introduces dual pilots. But that opens another problem: mental synchronization. To operate effectively, two minds must merge. Thoughts, memories, emotions, shared, no barriers. Now imagine that during combat: fear, pain, trauma, not just experienced, but doubled. The psychological toll alone could break pilots long before any battle does. And if synchronization fails mid-fight, the Jaeger freezes, or worse, it turns into an uncontrollable giant. Let's say we solve everything: structure, power, control. Now we face the final barrier: cost. Building a Jaeger wouldn't cost billions, it would cost trillions. For comparison, modern aircraft carriers already cost over $10 billion. Large-scale infrastructure projects push into hundreds of billions. A Jaeger, custom materials, experimental energy systems, advanced AI, global coordination. Each unit could exceed the GDP of entire nations. And here's the real problem. You wouldn't build just one. You'd need multiple units, maintenance teams, repair facilities, pilot training programs. This isn't a weapon. It's an entire economy dedicated to a single machine. And if one falls in battle, you don't just lose a robot. You lose years of global resources. Now let's step back, because here's where everything changes. Even if we could build a Jaeger, should we? A machine this large, this powerful, this unstable, isn't just a defense system. It's a walking disaster. One misstep could flatten entire city blocks. One malfunction could turn it into an uncontrollable force. One power failure, and it collapses, crushing everything beneath it. But the darkest part isn't the machine. It's the humans inside. Pilots connected at the deepest level of consciousness, sharing thoughts they were never meant to share, experiencing each other's memories, fears, and pain. Over time, where does one mind end and the other begin? The drift doesn't just connect pilots, it erases boundaries. And when the mission ends, there's no guarantee they come back the same. So, could we build a Jaeger in some distant future with materials we haven't invented, power sources we don't yet understand, and technology that can safely merge human minds? Maybe, but today, no, not even close. Because Jaegers don't just challenge engineering, they challenge physics, biology, psychology, and the limits of human control itself. But maybe the real question isn't whether we can build them, it's what it would mean if we did. Because the moment humanity creates something that powerful, something that blurs the line between machine and mind, we're no longer just building weapons. We're creating something else, something bigger, something dangerous, something we may never fully control. If you want more deep dives into the dark reality behind science fiction, where imagination meets terrifying possibility, hit subscribe, because the next story might not be fiction at all.